The authors of a review article argued that any reproducible violation of Second Law of Thermodynamics would be solved the world's energy problems at one stroke. These authors are right in the sense that we should use fuels to get useful work from heat only because of the Second Law of Thermodynamics. The Carnot principle, which we call as the Second Law of Thermodynamics since Clausius's time, postulated in 1824 that we cannot obtain a work from heat without a temperature difference, since the efficiency of the conversion of heat into work should be equal 0 in this case. We are forced to use fuels in heat engines, not to get energy, but to create a temperature difference. We are forced to burn fuel and heating the environment in order our cars can move, since the dissipation of the kinetic energy of the car into heat is an irreversible process according to the Second Law of Thermodynamics, or the Law of Entropy Increase. If a process reverse of the transformation of the kinetic energy into heat could be possible, then we would not have to use fuels and the movement of our cars would not be leading to the increase in the thermal energy of the environment. The main obstacle to solving the world's energy problems is the centuries-old faith of almost all scientists in the impossibility of a perpetual motion machine. Sadi Carnot postulated the need of a temperature difference to obtain energy from heat only on the basis of this faith. The perpetual motion machine is one of the oldest problems of science. The dream of a perpetual motion machine appeared, apparently, in ancient times, for those who, for example, did not want to push the cart themselves. The first attempts to invent a perpetual motion machine were known beginning with the 13th century, but already in the 15th century Leonardo da Vinci stigmatized its inventors equally with alchemists. The faith in the impossibility of a perpetual motion machine cannot have a scientific basis because of the fundamental changes in our ideas about nature over the past centuries. In Carnot's time, heat was considered a weightless fluid. Nevertheless, this blind faith has played a very important role in the history of the development of science and technology and has predominated up to now. A perpetual motion machine would be inevitable, according to the law of energy conservation, if all processes in nature were reversible, or if a process reverse of the process irreversible according to the law of entropy increase was observed. The power of belief in the impossibility of a perpetual motion machine is so strong that scientists do not notice such processes. For example, physicists do not want to admit that such a process is observed in the Meissner Effect discovered in 1933. The paradoxical nature of the Meissner Effect observed in bulk superconductors is especially obvious when compared with the movement of a car. An increase in the external magnetic field creates the Faraday electromotive force, which induces an electric current in the thin surface layer of the superconductor. This current does not decay arbitrarily long time, since the mobile charge carriers move in a superconductor without friction, i.e. without a dissipation force. A car would also move arbitrarily long in the absence of any friction. But when friction occurs, the electric current will quickly decay and the car will quickly stop due to the dissipation of the kinetic energy into heat. Friction occurs during the transition of a superconductor to the normal state. All physicists until 1933 were sure that during the reverse transition from the normal to the superconducting state, heat could not turn back into kinetic energy of the current. But Walter Meissner and Robert Oxenfeld discovered in 1933 that just this process reversed to the irreversible thermodynamic process as observed. The Meissner effect is similar to how if a car could start moving not only without fuel, but also in the absence of a driving power, and uphill. In order not to have understood that they were observing a perpetual motion machine, physicists had to postulate a contradiction with the law of energy conservation.